Section 4.2, trig functions and the unit circle. So, here we go. We want to find all 6 trig values given this information. All right. So, what we're going to do is, well, what I do is I draw a whole bunch of little pictures because I think it helps me. So, what I'm going to do is I'm going to draw a little picture that represents this situation. So, I'll take out my little tiny coordinate, I mean, not tiny, but large enough that I can write some stuff in it because I'm going to need a triangle as well. All right, the first piece of information I'm going to take a look at is the second part here with the cosine theta. All right, that says that cosine is greater than 0. If cosine is going to be greater than 0, then cosine has to be positive. Well, cosine represents the x value, or in the x location, so I want my x's to be positive, which means I have to be to the right. So, being to the left is not going to work. So let's cross out the left part. I know I'm not going to be over here. Alright, so that takes care of the cosine theta part. Now let's take a look at the other part here. This whole tangent theta is equal to -7/5. I'm not going to look at the number just yet. I'm just going to look at the sign on it. So it says the tangent is negative. Well, I only have 2 quadrants left. I've got the A quadrant, which is all positive, and I've got the C quadrant where cosine and secant are positive. I need tangent to be negative. Well, tangent's positive in the first quadrant, which means it's going to be negative in the fourth quadrant. So let's cross off the first quadrant here. All right, with that said, now I should be able to draw a triangle that represents this information with the section that's left over. So I'm going to draw my triangle down here. I'm going to go ahead and fill in the information that I know. So there's my theta, and then I know that tangent is going to be opposite over adjacent. So my opposite side is going to be -7, my adjacent side is going to be 5. Okay, so now that we have our picture, let's go ahead and use the Pythagorean Theorem, just like we normally would to find the hypotenuse. So if I do 5 squared, that's 25, 7 squared is 49, 25 and 49 gives me 74. That can't be simplified, so I think I'm just going to leave it as the square root of 74. Now that I have my picture and I'm in the correct quadrant, I'm going to go ahead and pause and see if you can find the 6 trig. Okay, so here are the 6 trig that I got. Remember a couple of things. 1, you have to rationalize if there's a radical in the bottom of the fraction. 2, you need to make sure that if you can simplify a fraction, you have to simplify the fraction. Likewise with radicals. If you can simplify the radical, you have to simplify it. One of the things that was nice about this is neither of those even came up, so I didn't have to worry about it. Third thing you need to remember is what quadrant you're in. So I am in the C quadrant, which means the only things that should be positive are cosine and secant. Always take that extra little step at the end and check your signs. So cosine and secant are positive, everybody else is negative. I'm confident in this answer. Let's go ahead and take a look at the second problem. So I'm going to do the exact same thing here. Big fan of a whole bunch of little pictures. Now, I don't think I need as big of a picture this time because pi is on one of the axes. So I know that pi is over here. And what I think I am going to use is the actual points. So this is going to be -1, 0. Remember that the x value is going to help us with cosine and the y value is going to help us with sine. So I'm going to pause again, see if you can find all 6 trig, and then we'll check and see how you did. So you'll notice the other ones that I haven't filled in are the cosecant and the cotangent. And that's because I just wanted to make sure that we were on the same page together here. So sine, I looked at the point and the y value was 0, so that's 0. Cosine of pi, the x value is -1. Tangent of pi. In situations like this, and actually a lot of the time, I like to use the fact that tangent is sine over cosine. So I take a look at the 2 values above and I just make them into a fraction. So it's going to be 0 over -1, which is just 0. Taking a look at the secant, again, it's the reciprocal for cosine, so I'm going to flip over the -1, but the reciprocal of -1 is just -1. All right, cosecant and cotangent. I still want to use the idea that they're the reciprocals of their other functions. So for cosecant of pi, I would look at sine and I'd flip it over. But in flipping it over, I would put 0 in the bottom of a fraction. Now, just to remind you, 0 in the bottom of a fraction is referred to as defined. So UD is perfectly fine for you to use. So those are my 6 trig now for my theta is equal to pi. All right, here's my next one. Now 45 degrees sounds awfully familiar to me, like it's on the unit circle. So I don't think I need a large triangle here. I think I just need to have a large triangle, large set of axes. I just need a general idea of where this thing's going to be. So negative 45 degrees, which means I'm going to have to go down from the x-axis. 45 degrees is dead center in the middle of a quadrant. So I would say that that angle is the angle I'm looking at. All right, so this is a reference angle of my 45, 45, 90 triangle. You're welcome to take your unit circle out from your notes. Take a look at where this is located. Use the fact that the x value is going to represent the cosine and the y value is going to represent the sine. I'm going to pause and let's see if we match. Okay, so here are my 6 trig. And again, you're welcome to use the unit circle at this point as we're studying and getting ready. Remember, on the test, you do need to be able to get this information on your own. Notice that I'm in the C quadrant again, so I'm going to do a quick check on my signs. I see that cosine and secant are both positive. Everybody else is negative. This is good. I also know that with a 45, 90 degree triangle, that the legs are root 2 over 2 and the hypotenuse is 1. So my sine and my cosine, representing the x's and the y's, should be root 2 over 2, either positive or negative depending on where they're located in the coordinate plane. And then cosecant and secant, when you rationalize those, you're going to end up with 2 over root 2. Multiply by root 2, you get 2 root 2 over 2, and the 2's cancel. So you have left is the root 2 itself. Let's take a look at the next one. Okay, so a couple more examples, and then we'll be done with this section. So a little bit of practice with the unit circles. Basically all that's happening here. All right, so now I've got a 7 pi over 6 or a negative 7 pi over 6. Now I'm going to blow this one up just a little tiny bit bigger because I want to show you something that I do that I find helpful. Now this is not required at all. Notice that nowhere on this does it say that you have to draw the pictures. I'm a big picture person, so I like drawing the pictures. All right, so negative 7 pi over 6 is just past negative pi. So there is negative pi, and then I need to go an additional pi over 6, which is just a little tiny bit past. So that's where I'm located. So here's what I do when I draw the pictures. Whenever I have a pi over 6 reference angle, all of my pi over 6's look kind of shallow. They're close to the x-axis, so that side is close to the x-axis. It doesn't stand up really tall. So I draw it that way because I find it helpful when I'm trying to figure out, well, is the side a half or is it root 3 over 2? I know that root 3 over 2 is larger than a half. Because of that, just by looking at the picture, I know that the short leg is the half and the long leg's the root 3 over 2. I don't even need to look at the unit circle for this. It's just something that I've basically trained my brain into recognizing. So with that said, you're welcome to take out your unit circle for this. I'm going to go ahead and pause, fill in all of my values, and we can check. Okay, now on to our last example, number 5. 16 pi over 3, so I'm going to do the exact same thing I keep doing. I'm going to draw a little picture. Alright, so 16 pi over 3, you can do this a couple of different ways. You can find a coterminal angle by subtracting 2 pi's until you get down to something that you're used to in the unit circle, or you can just kind of spin your way around until you get it, and I think I'm just going to keep spinning. So I know, and I'm just going to count. So there's 1 pi, which is really 3 pi over 3, 6, 9, 12, 15, 16. So I think I'm down here, assuming that I counted correctly. All right, you'll notice too, make sure that I draw it as steep as I want to. Whenever I have a pi over 3 reference triangle, the pi over 3's are tall or steep. They're far away from the x's and pretty close to the y's. Kind of like with the pi over 6, it helps me remember where the half is and where the root 3 is. So, or the root 3 over 2. So let's go through and take a look at this picture. So I'm going to do the same thing that I've been doing. I'm going to pause it for just a second. I'm going to fill in the 6 trig. I recommend that you do the same and then just check and see if we match. Okay, so here are my 6 trig. I wasn't able to put those sign and the cosecant next to each other because I started writing it a little bit too high and it was going to run right into my graph. So you'll notice that I am in the T quadrant, so only tangent and cotangent better be positive, which they are. That's good. And I know that the sine value is the y and it's pretty steep. So it's far away from the x-axis, which means my y value is going to be the root 3 over 2. And because it's down, it's going to be negative. Likewise, the same idea with my cosine of 16 pi over 3. And then make sure that you rationalize everything else if you have the root 3 or the root 2 in the bottom. And I think that does it for this section.